Everyone. Today we're going to be talking about representing the path of a single Ferris wheel. The objective of today is to try to use trigonometry to determine the height of a Ferris wheel. So let's take a look at the problem. A Ferris wheel has a diameter of 50 feet and is suspended from a tower 40 feet above the ground. So these are some important numbers. The wheel revolves every 10 seconds in a counterclockwise direction. Write a function that describes a rider's height above the ground as a function of the number of seconds since her start. Use the following questions to help develop the function. So let's just look at a diagram. So in the problem it said the diameter of the Ferris wheel was 50 feet and the height that the Ferris wheel was suspended above the ground was 40 feet. So we want to develop a function that tells us the position of the Ferris wheel rider, their height, as a function of time. So we know in our equation we're going to need time. So how can we model the height? So the height of the function is similar to if we were looking at the unit circle. It's very similar to the height or the y-coordinate on a unit circle. So we know from our study of trigonometry that that the y-coordinate is represented by the sine function. So we know somewhere there's going to be sine function involved. Okay, so now given that information, how can we determine the function itself? We know since the height of the wheel is 40 feet off the ground, that's going to represent a vertical shift. So if we write our function f of t, it's going to equal 40 plus something. I'm sorry. Hold on. We know there's going to be some sort of a vertical shift, but it may not be 40. If we were to find the height at the initial position, the initial position is right here in red. Okay, so initially at time 0, the person is 40 feet in the air, so we could make a table. So we can have time and the height. So at time t equals 0, the person is 40 feet off the ground. Now we are given the information that the period, or the time it takes to complete one full revolution, is 10 seconds. So after a quarter period, the person is right over here. Okay? So a quarter of 10 seconds is 2.5 seconds. So after 2.5 seconds, the person is at a height of 40 plus half the diameter, which is 25. This distance right here. So 40 plus 25 is 65. The height is in feet. And the time is in seconds. Okay, halfway through, we know the person's right here. They're going to be the full length of, or the full distance from the ground, including the diameter and the height of the wheel itself. So it's going to be a total of 90 feet. Right? This is 40, that's 50, that makes 90. 3/4 of the way through, at 7.5 seconds, we know that the person is back at the same height they were at a quarter of the way through, so 65 feet. Now, how can we model this using trigonometry? Since the height can be represented by a sine function, I know I'm going to need to have the sine function. Okay. Now the sine function typically starts at 0, right? It goes at 0, goes to its maximum at pi over 2, and then at pi it goes back to 0, then it's a minimum at 3 pi over 2, and then at 2 pi it's back to 0. Whereas in this case, the person initially started at the minimum. So we know there's going to be what is called a phase shift. So we can rewrite this equation as sine of b times theta plus we can represent the phase shift as phi. Okay, since the period is 10 seconds, we know 2 pi over b is going to equal 10 seconds. So we can solve for b by cross multiplying. So 2 pi equals 10b. So b, when we divide both sides by 10, gives us 2 pi over 10, or pi over 5. Okay, so we know that b is pi over 5. Now how can we determine what phi is? And I made a mistake here. There should be a t, because it's a function of time. At time 0, we know the argument of this function has to be equal to negative pi over 2. Why is that? So let's think about it. So at time t equals 0, if we look at the unit circle, the writer is at a degree measure of negative pi over 2 relative to the positive x-axis. So if we look at this and we plug in 0, we get pi over 5 times 0 plus phi equals negative pi over 2. Okay, solving for phi, we get phi equals negative pi over 2. Okay, so now we have everything we need to figure out the height. So let's try to write it up here. So the equation is going to be f of t equals we know we have sine of pi over 5 times t minus pi over 2. Okay? So at time 0, we get sine of negative pi over 2, which is negative 1. If we multiply that by the radius, which is 25, we get negative 25. So we know this can't represent the height. The height is going to be a positive number. So we're going to have to add in another value. So what value should that be? So at time t equals 0, we know we're at 40 feet. So this value here is negative 25. So we know we're going to have to take this 40 plus the radius, right? So we're going to have to take 65 and add it. Okay, if you think about the graph and the origin being right here, this graph has been shifted vertically by 65 feet to the new, what they call the midline of the function. The midline is right here. So it's been shifted 65 feet. So this is the equation of the height. So if we wanted to plug this in a calculator, we could. We may not have time for this, but let's try it. 25 sine of pi divided by 5 times t minus pi over 2 plus 65. Now we're going to have to adjust the window. So the minimum, this is at time 0, we know that's where the rider is initially here, and then after one period. So why don't we plot 2 periods? Okay. The x scale. Why don't we set the x scale equal to 1 period? The minimum we could say is 0, and the max is going to be at least 90, so 100. And each increment can be 10. Let's graph this. So does this correctly model what we've shown? We can test it by looking at the calculation function. Let's calculate a value. So we know that a quarter of the way through the period at 2.5, we should get a value of 65, and we do. And we're running out of time. Hope that helped you solve that problem. Look forward to solving other problems in the future.